Hi, in this video I'm gonna show you again how you can transform the standard form of quadratic function to vertex form in a couple of examples, and I will go through the function f1, function f2 and function f3, and I will show you how to do this procedure by completing the square method in these three examples. So let me start with the first function, which is given by the equation y equals x squared plus 6x plus 8, and I will at the very end show you again that there is an easier way if you can remember the formula how to calculate the x and the y coordinate of the vertex. So to complete the square in this example, I took this one, as this one is really simple and there is nothing scary about this, and nothing like very hard. So the first thing, if you remember, you are looking for the vertex form, which is this one. Okay, so you want to rearrange this function in to this square or vertex form. Basically there is a which is equal to 1, so there won't be any number 8 a in front of the parentheses, so you just write it like x squared plus 6x the end of the parentheses plus 8. Okay, now you are looking for kind of perfect square and you want to complete this square or this expression to become something like x squared plus 2ab plus b squared, which is then equal to a squared a plus b squared. Okay, so how do we do? As I was explaining in the previous video, it's really simple, because there is a equal to the coefficient a is equal to 1, so you can very easily find that this is gonna be x squared plus 6x. And the main thing to remember, or you can find out how, is that this one is gonna be like half of coefficient or of the number 6. Half of 6 is 3 squared, okay, plus 8, but as we added here now the number 9, we have to take away number 9, so that this expression is really the same thing as the expression above. If you want to really be sure that it is true, you just try x squared plus 6x plus 9 plus 8 minus 9, and as you can see here, these 9s will cancel each other and we are back to the same expression at the very beginning. Now, applying the formula, we know that this expression can be represented like y is equal to x plus 3 squared, and positive 8 take away 9 is equal to negative 1. And from this expression you can very easily read the coordinates of the vertex, and these are negative 3 and negative 1. Okay, some of you may ask how did we find negative 3? There are two ways how to do it, and the first thing is to realize that the vertex form is given like x minus parameter k. Okay, so how can we rearrange this expression? The answer is very easy. It can be written as x minus, and as we want to have the positive 3, it means negative 3, okay, minus negative 3, which is plus 3 squared minus negative 1. That's why you can see from here that the first coordinate of the vertex is negative 3 and the second coordinate is negative 1. Okay, so this is how you can find it very easily using or modifying the expression so that the negative sign is in front of the number. Another approach is very simple, and you just ask yourself when x plus 3 is equal to 0, and the answer is of course when x is equal to negative 3. Okay, so these are two things or two ways how you can find the first coordinate of the x coordinate of the vertex. Okay, now I want to show you again how you can come, like vice versa, from the vertex form to the standard form. And this one is really easy and simple, because you simply multiply x plus 3 squared, take away 1, which is of course, by using the formula, x squared plus 2 times a times b, so it is 2 times a times b plus b squared, which is 9. Okay, take away 1, and this one is equal to x squared plus 6x plus 8. And we are back in the standard form of the quadratic function. Okay, so as you can see, coming or going from vertex form to standard form is easier than going or finding the vertex form of the quadratic function to standard form. Now I want to prove that this one is really correct, and I want to prove that what we already know, that the vertex coordinates can be calculated as negative b over 2a, and then there comes the special formula, which I really don't remember, because I don't really like remember. I don't want to, and I don't like to remember any special formulas, and in my case it's easier to calculate the value of the function for negative b over 2a. Okay, so what it basically means, you just take the standard form here and you find out that a is equal to 1, b is equal to 6, and c is equal to 8. So far you have all important information, and you can evaluate at least the x coordinate of the vertex, which means negative b over 2a is then, based on this information, this one is equal to negative b is 6 over 2a, which means 2 times 1. Oops, sorry, I wrote b instead of 6. So this is 6 over 2 times 8, which is 2 times a, which is 2 times 1, and this is really equal to negative 3. As you can see, we are right. The x coordinate, by completing the square method, we found the same number, and now we will try to find the value of the function for x being equal to negative 3, which is negative 3 squared plus 6 times negative 3 plus 8, and this is 9 plus, minus 3 times 6 is 18 plus 8, and this is equal to 9 minus 8 minus 18 plus 1 is negative 1, which is also true, and you can see that we found the coordinates of the vertex very easily by using the formula for the coordinates of the vertex. Okay, let me do the same thing for for the second function named f2. Let me do it down here, and we do the same procedure now. Maybe some of you are scared or afraid of this fraction 3 over negative 4, Let me rewrite it so that you can see it in a nicer way. 3 over 4, okay, and the same procedure applies here. Y is equal x squared minus 3x in parentheses, because we will now complete the square, minus 3 over 4. Now you ask yourself, what number should we place like here, so that we can simplify it to something like x minus some number. Let me put it, in this case it's gonna be square root of this one, but it doesn't matter. So what is the number we have to put here? And we already know that this number is half of 3, so we do half 3, which is in this case plus 3 over 2, and it must be squared, okay. Take away 3 over 4, and as we added here this number, we have to take away the same number. Let me just write it nicer. We have to take away the same number, which in this case is 3 over 2 squared, and it is 9 over 4. Okay, to simplify this one, it means that it's gonna be x minus y minus, because here is negative sign, and in this case we use the formula a take away 2 times ab plus b squared is equal to blah blah blah. In some cases, if here is positive sign, which was in this case, we used another formula which says a plus 2 times ab plus b squared is equal to a plus b squared. In this case it would be, or it is, a minus b squared. Okay, so these are two formulas we are using when we do complete the square, or we transform from the standard form to vertex form of the quadratic function. Okay, so we can write this one as x take away 3 over 2 squared, take away the common denominator is 4, and it's gonna be negative 3, negative 9, so it's gonna be negative 12 over 3, which can be simplified a little bit more, and it is gonna be x minus 3 over 2 squared minus 12 over 4 is equal to 3. So the vertex coordinates are now 3 over 2, and the second one is gonna be negative 3, because the vertex form of the quadratic formula says that it is something like this: x minus k squared plus h, and this is the first coordinate and this is the second coordinate, or if you want to, x and y coordinates. Okay, now let me prove this one by using the formula sorry, for calculating the vertex. As the vertex is calculated as negative b over 2a, and f of negative b over 2a, we can find or read from this formula that a is equal to 1, b is equal to negative 3, and c is equal to negative 3 over 4. Negative 3 over 4. Now the x coordinate is gonna be calculated from the expression negative b over 2a. This is equal for these coefficients as negative b is negative 3 and 2 times a. Okay, sorry, not 2 times a, but 2 times 1. So this is gonna be negative 3 over 2, negative times negative which in this case this negative sign can be understood like negative 1 times negative 3 over 2, or if you can remember, this is something like negative of negative 1, which is equal to 1. Okay, there are two ways how you can understand this procedure I'm gonna use now. So our x coordinate of the vertex is, after this procedure, gonna be 3 over 2, which is correct, as you can see. Okay, Now we have to calculate the value of the function at 3 over 2, which is equal to 3 over 2 squared minus 3 times 3 over 2 minus 3 over 4, which is equal to 9 over 4 minus 9 over 2 minus 3 over 4. So you look for the common denominator, which is number 4. So it's gonna be 9, take away 18, take away 3, which is equal to negative 9, negative 12. Okay, it's gonna be negative 12 over 4, which is equal to negative 3. Okay, so we are again right, and this is it. Okay, so who is interested, who is not willing to remember the whole formula for how to calculate the vertex, this is one of the ways you can find the coordinates of the vertex. Now let's have a look on our last example, which is function f3, and okay, we have enough space here, so let's do it again both ways by completing the square. As you already know from my previous video, the first step is to take 3 out of the brackets or parentheses, which is then gonna be 3 times x squared minus 2x minus 6. Okay, we now want to complete this square, so this is gonna be 3 times x squared minus 2x. Half of 2 is 1. I will write it like 1 squared. Okay, now minus 6, and now you have to realize that you added like 3 times 1 squared, which is equal to 3. So as you add up here number 3, you have to take away 3 from this expression so that you have the same expression. And now if you simplify this one, it's gonna be 3 times x minus 1 squared minus 9. You can read from the vertex form that the vertex coordinates are 1 and negative 9. Let's prove this one by using the formula vertex x coordinate negative b over 2a, and the second coordinate is gonna be the value of the function at negative b over 2a, which in our case means, again you have to read properly parameters. A is equal to 3, b is equal to negative 6. Basically you don't need, for calculating the vertex coordinates, the value of the coefficient c, but I will provide this information here. So it's gonna be negative 6, and now you just calculate negative b. Let me use black pen. Negative b over 2a is equal to then negative b, which is negative 6, over 2 times 3, which is negative of negative 6 over 6. And as you can see, and you probably understand, this is gonna be 1, which is really the x coordinate of the vertex. And now you just calculate the value of the function at 1, f of 1, which is equal to 3 times 1 squared, take away 6 times 1 minus 6. This is equal to 3 minus 6 minus 6, okay, which is equal to 3 minus 12, and this is equal to negative 9, which is really again the same number, which is the value of the y coordinate of the vertex. Okay, this is how you do when you want to use the vertex form of the quadratic function. Okay, I'm not gonna explain any other details because there is a lot to say about it, but basically this is how you can use the complete the square method to come from the standard form to vertex form, or if you want to find the coordinates of the vertex by using the complete square method, or if you really just if you are really just okay with remembering or with learning the formula how to calculate the vertex, you can come to the same result with maybe less effort. So thanks for watching, and see you during our next video. Bye bye.